Okay, today we're going to talk about how to solve by graphing, and we have three cases to consider. The first case to consider is when you graph, you end up with some type of quadratic. Could be a parabola, could be a circle, or a couple other things. I'm going to go with circle this time, and a line, and maybe you draw it like that. And I have a circle cross with a line crossing it. And our solutions are the intersection points. So we have a solution there, we have a solution there. That's what a solution to a system means, is our intersection points. So there's two places intersect. So we should be looking for two solutions. This happens a lot of the time. But we have a couple special cases. So let's say that we have our parabola. This time I'm going to do an oval just so that we have a different type of parabola. And maybe instead of crossing at two spots, it crosses at only one spot. Like maybe it crosses right there. Okay, this is called tangent. Means it crosses at only one spot, and there would only be one intersection point. So we have cases where there's one intersection point. In this case, it would be called one solution. And there's one other case, and that is, let's say that I have. This time I'll go with our standard parabola, and my line doesn't touch at all. And now we have zero solutions. So this is our case for zero solutions. Okay, and sometimes you use the quadratic formula in this case. And when you use the quadratic formula, if you end up having imaginary solutions, imaginary solutions, you're going to say that there are zero solutions. So we're talking about real solutions, and there are no real solutions. So you don't have to worry about what the imaginary number is. As soon as you recognize it to be imaginary solutions, then you know that there are no solutions to your system, because solutions are where it actually happens, and there are none here. Okay, they end up being imaginary, which is why there are no solutions, because you can't see them. They're imaginary. It doesn't cross at all. So in the real world, it has no meaning. So don't worry about finding the exact solution. Just know if you are starting to get imaginary numbers, you can stop and you just write there are no solutions. It doesn't cross at all. This case, sometimes you end up with the same solution twice. That's okay. It still means there's just one point, but in the quadratic, it ends up coming as a double point. And then, of course, you have the two solutions up here that we've seen. So let's say we're going to solve this by graphing. Well, the way you're going to solve it by graphing is I actually have to graph both lines. So let's start by having a coordinate grid. You can also obviously do this on your calculator. So if you want to do it on your calculator, it's fine. But I'm going to show you how to do it without a calculator, just in case you have that problem. And we're going to start by graphing. I'm going to graph the quadratic first, and I know that when I don't have anything over here or anything in here, that it's going to start at 0, 0. We can verify that by making a table. So let's make a table with x and y, and I know a 0 is the solution, because if I put in 0, I get 0 squared is 0, and 0 times 2 is 0. So we have 0, 0. I also know it's going to open up because this is positive, and I'm going to find out what the next couple points are. So if I put in 1, I get 1 squared is 1, and 1 times 2 is 2. And let's try 2, and if I do 2 squared, I get 4, and 4 times 2 is 8. So I have some points here. And I know if I put in the negatives, they're going to mirror this. You can verify if you want. Negative 1 squared is 1, 1 times 2 is 2. And of course, this is also going to be 8. So I can now graph it. I'm going to need 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we get 0, 0 as one solution. I got 1, 2, and negative 1, 2. And I got 2, 8, which is way up here, and negative 2, 8. And then we're going to complete it with a nice looking parabola, which is not very easy to do on my tablet, I'll have you know. Looking something like that. So we need our second solution, and I'm going to do this one in blue. Our second solution is to graph our line y equals x plus 3. This is in slope-intercept form, so the intercept is at 3. So we go up 1, 2, 3, and put a dot. And our slope is 1, so it's going to be up 1 over 1, up 1 over 1, up 1 over 1. And we can go the other way, down 1 over 1, down 1 over 1, down 1 over 1. Okay, so there's our nice slope. And the nice thing is I know one of these intersection points. It's right here, because when we graphed it, we ended up getting this point negative 1, 2, and I ended up going through it. So one of our points is really easy to find. It is at negative 1, 2. So I already found one of the intersection points, but this intersection point is harder because it's somewhere between the 1 and the 3. The 1 was at 2 and the 3 was at 8. So this is going to be some kind of fraction or decimal. And you're going to have to either guess at it very carefully, or you're going to have to use your calculator. And your calculator should give you a much more accurate answer. Just looking at it, it's going to be somewhere around 1.5. And it looks like 3, 4, maybe a little more than 4.1. So somewhere in that area there. But that's not a very accurate answer. So this one's very accurate, negative 1, 2. I clearly know that one. This one's a guess. This is the big limitation about doing it with the graphing method. So I would recommend most cases, unless you're going to use your calculator, which is fine, you should probably using the algebraic method, because this method is going to give you exact solutions. But you do need how to do it without exact solutions. But these cases are going to be very simple, and the ones I give you on quizzes, if we have to do this, they're not going to have these weird decimals and fractions. They'll be nice and easy ones with exact answers. But just understand that that's what it is, and especially understand the limitations. Okay, so if you have any questions, let me know. But when you graph it, you should end up with either 2 intersection points, which you're looking for, 1, or none.